Well, g'day. It is Ken Colson here again from Creation Unfolding, and today I've got Dr. Matt McLain again from the Master University. Matt, how you doing today?
Hey, doing well. How are you?
Good, good, good. Great to see you. So today, tell us, what are we going to be talking about?
We're going to talk about Tiktaalik, and we're going to talk about whether or not you evolved from a fish.
Okay, interesting. Now, I have heard of that fossil. It's pretty significant for various reasons. Maybe you could fill us in on that.
Yeah, absolutely. So I've actually got right here, this is a 3D printed replica of the original, the holotype, right? The type
Wow.
specimen of
Yeah,
Tiktaalik, its skull. So they
that's
found
the
more of
that's a
it.
3D print.
Yeah,
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 very
it's really
cool.
good detail too. I mean, you can
It
see the little
is.
teeth and all kinds of fun stuff on it. And so, yeah, this guy is a big flat-headed fish. Okay, so you can see this is where the eyes would go, right? Then what's interesting about him, number of things. So he is a fish. I mean, you can find fins. We'll talk about the fin in a minute and scales and stuff. But Tiktaalik actually has a neck. Okay, so you can see the skull ends right here, and you would have the neck begin here and the rest of the body. And so Tiktaalik can actually move its head separately from its shoulders.
Hmm.
And you're like, big deal. Most animals you feel like can do that. Well, actually, fish, they have all these extra bones right here called the opercular bones, and they
Hmm.
surround the gills and they connect back to the shoulder girdle, the shoulder blade, what
Right.
it is, shoulder blade, and to the fins. And so when a fish wants to look at something, it actually turns, its fins with it. But Tiktaalik can move its head separately, right?
Hmm. Okay.
Um, the other fun thing, and I've actually got, and this one's a little bit harder to see, this is the fin of Tiktaalik, and
Yeah.
this is still kind of encased in rock a little bit. That's how we 3D printed it. So it's a little bit hard to see. But what you can see, there's one bone right here,
Yep.
right? And then that one bone becomes two bones, and then it becomes littler bones up here.
Right.
And so this we think is homologous, right? It's the same structure of the humerus
Yep.
and the ulna and the radius. And then above the ulna, there's one of these little bones right here. And I don't know how close we can get here, but there's actually an articulation surface between these two bones,
Hmm.
where it can move. And so it looks like it actually had movable joints in its fin, and one that corresponds to our wrist joint that it could move right there.
Yeah.
And so you've got a fish with a head that can move around separately from the body, and can prop itself up on its fins, maybe a little bit underwater.
Hmm.
And that looks like a really convincing transitional form, right? An evolutionary missing link, right, between fish and your four-legged animals, which would be
Right.
your amphibians, reptiles, birds, and mammals.
Yeah. So if you were an evolutionist, this would kind of be fairly
Right.
convincing for you.
Yes, that's kind of the idea. And that's when Tiktaalik was announced in 2006, it was announced as just the proof of evolution. Like people spoke of it as if, this is the final nail in the coffin. This is the best evidence for evolution ever. Actually, in my paper that I wrote up about this from a creationist perspective, I quoted from, I think it was a New York Times article. Let me see if I can find it here.
What's the name
Where
of the paper for viewers? You might want to go
Yeah,
find
yeah,
it.
yeah. Well, here I'll just it's called "Do You Have an Inner Fish?"
Okay.
And it is published by the Journal of Biblical Creation Trust, which is called E-Origins. It's free online. You can download it. And the journal is designed to have articles that would work for like a semi-technical audience, right? So if you're at all familiar with this kind of stuff, you should be able to kind of follow it for the most part, which is cool.
Yeah.
And so I wanted to, let me see if I can find it. Oh, here we go. Okay. So the New York Times article said Tiktaalik was a powerful rebuttal to religious creationists who hold a literal biblical view on the origins and development of life.
Mm.
Okay. National Academy of Sciences Institute of Medicine put out a statement called Science, Evolution, and Creationism in 2008. And they said Tiktaalik was critically important for confirming predictions of evolutionary theory.
Mm.
So everybody's kind of jumping on this as this thing is it, right?
Right. So
That's
you
the
said it
thing to
was it
follow.
was the proverbial nail in the coffin, but you're going to tell us that it wasn't the proverbial nail in the coffin, at least not as much as they expected it to be.
Right. That's what it seemed that way. And I see why people said that kind of thing. But, as we often talk about in creationism, a lot of our job is patience, right? We've gotta be willing to stop and do the research and wait things out. And when we do, we often, eventually, we discover that, you know what? Science does match what the Word of God says, right? It's just that it takes that time and energy and effort. And that's exactly what I'm going to say in this article is that, in fact, Tiktaalik is not this amazing nail in the coffin that they thought it was.
Hmm. Okay, tell us why. Why is that? There's a
Yeah,
story behind
absolutely.
this, right? A scientific
There is a story.
story and a
Yes.
story that we can learn from.
Yes, absolutely. So, let me show you Tiktaalik really fast. Okay, so you can see right here, this is the original fossil Tiktaalik that was found.
Yep.
Okay.
There's that
So
skull that
there's
you
the
showed us.
skull. Yep. There's the rest of the body. You can see most of the body. You don't have the back part of the body. We'll talk about that later. And it's got some fish characteristics. It's got some tetrapod characteristics we already talked about. Here's the back end of the body. Okay. So they did find the back limb. And then there are lots of other Tiktaalik specimens. Okay. So this is not just a one-off, like if you go to the spot. So how did they find this thing? Right. This is where the story part comes in. So there were three scientists, and they were interested in finding the transitional form between fish and amphibians, right? So if we go back here a little bit, we can see this is kind of what was known for a long time for the most tetrapod-like fish. Okay, the fish that has the most in common with four-legged animals, right? Because in evolution, everything has to come from somewhere,
Right.
right? So four-legged animals have to evolve from something. They knew it's got to be some kind of lobe-finned fish, okay?
Mhm.
And so Eusthenopteron was a really good example of one. And what was special about Eusthenopteron that you don't find in other fish, like living fish, is that it had nostrils more like us. Okay, so you can see the external opening,
Mhm.
right? Where, for us, air goes in, for them, water goes in. In a normal fish, they actually have nostrils on the front, like where you could see it on the side of the fish, right? And so water goes in and then goes out. And they're not used for breathing. It's just for smelling. That's all it does.
Mhm.
In us, however, when you breathe in through your nostril, right, the opening is in your mouth or at the back of your throat, right?
Mhm.
It's inside, and the air can come in there, and it obviously goes the same place as the air that comes in our mouth. Okay,
Mhm.
Eusthenopteron does have openings on the roof of its mouth,
Mhm.
so water would come in the nostrils and actually go into the palate, or air if it's going up and gulping air or something like that.
Mhm.
And so they said, well, there you go. That's something that's leading to four-legged animals, right? Leading to walking on land, for instance.
Mhm.
Problem is, you look at this animal, Ken, what kind of animal is that?
It's fish.
It's a fish. It's very much a fish, right? Nothing in the rest of this animal says, I'm turning into something with legs, right? It's a fish, okay?
And we have fish kind of like that today too, like coelacanths.
Yes, so there are some lobe-fin fish today. They don't have the funny nostril thing, but they do they're in the same basic group as this thing.
Right.
So we also knew that there were some four-legged animals in Devonian rocks, things like Ichthyostega. But you look at this is not a fish. This
Mhm.
clearly has legs with fingers and toes,
Right.
right? Now it's a little bit weird, right? So here's Acanthostega, Ichthyostega, these two that are known. And you can see they actually have like lots of fingers and toes.
Yeah.
So Acanthostega has 8 fingers, 8 toes. Ichthyostega has 7 toes. We actually don't have a hand preserved of Ichthyostega, a full hand, so we don't know for sure.
Mhm.
Probably had 7. But yeah, that's a little bit strange, right?
Mm.
But your problem is, if we go back to the last slide, there's still a huge gap here between a fish and something clearly with legs,
Right.
right? And so these three scientists, they wanted to find that animal, that thing that was in between these two, the intermediate between a true fish and a true four-legged animal.
Mhm.
Okay. And so they knew what it was going to look like. They had to say, okay, where are we going to find it? So in terms of the stratigraphy or the when we might find it, you could say it that way. They knew it had to be in the Devonian, and it had to be in a very particular spot in the Devonian. And actually, let me show you in my paper, I've got a little diagram that shows this. So I'll pull that up so we can see. Right here. Okay. So here's the Devonian.
Yep.
So that's part of the Paleozoic rock record. So kind of right in the middle of the Paleozoic. And when you break up the Devonian into even smaller divisions, okay, Eusthenopteron, that kind of fish was known from the Gavetian. Our four-legged animals, our first ones are in the Femmenian. So things
Right.
like Ichthyostega and Acanthostega. So they're like, we got to look in the Phrasnian, right? That's where that transition is going to take place. That's
Right.
what they said.
And there's
And so
multiple millions of years between these two, right?
yes, correct. Yeah. So they're saying, okay, we know what it's going to look like. We know when it's going to be stratigraphically, right? Now, where in the world are we going to look? So they said, oh, we're going to go look in the Arctic Circle. And the reason they're going to look there is all of these guys are also from very far northern North America. So they're saying we got to look in those rocks in that particular part of the world. So they picked an island, one of the Canadian islands, and they said, this is where it's going to be.
Hmm.
Then fourth thing, what kind of depositional environment are we going to look in? So they said, we don't think it's going to be marine. We think it's going to be like a deltaic kind of thing. Okay, so like a delta, like kind of marine going into fluvial, somewhere in that range. So we're going marine to a river, you know. So that's kind of what we expect. So they do all that and they discover Tiktaalik,
Hmm.
right? So it takes them a few field seasons, but they find it. They find an animal that looks transitional between fish and amphibians or fish and tetrapods. They find it in the right rocks, in the right part of the world, in the right deposition environment, exactly where they thought it would be.
So using their scientific hypotheses,
Right?
they're obviously their presuppositional ideas. They've gone and they found it and they've said, hey, science works.
Yes, absolutely. And that's how science should work, right? Is that we make predictions, we go out and test those predictions. And so you can see why this sounds like such a powerful story,
Right.
right? And it sounds like such a good confirmation of the evolutionary model.
And
Um,
it was actually the confirmation of the hypothesis and their presuppositional ideas about this that actually weighed in heavily on the fossil too, right?
right, sure. So, and these are more images here you can see of why they think Tiktaalik would be a transitional form.
Right.
Um, so that's 2006. Okay. What's the creationist response to this? So they do respond. They talk about how Tiktaalik, it has a mosaic of features, right? And so they're saying maybe that's God's adaptation, or God's design, right? God designed this creature to live in a very particular environment, and so it has both fish and tetrapod-like features. Okay, that's reasonable. Um, but what these articles that come out, and there's several of them, and they've got some good things to say, what they don't address is the prediction fulfillment.
Right.
They don't talk about that. And that's a problem, right? Because it needs to be discussed.
Mm-hmm.
And so evolutionists were just saying, yeah, you creationists, come on. Like, how can you not believe this, right? This is clear, this is obvious. Okay, 2010 rolls around and some fossil tracks are discovered in Poland. Okay, so here's one of the examples, one of the tracks. You can see toes on it. In fact, it looks like it might have more than 5 toes, which is interesting, right? That kind of matches what we'd expect to see. And there's even footprints. So here you've got a foot and a hand, a foot and a hand, and you can see an animal was walking.
Yep.
Pretty wide stance that it's walking with. But Tiktaalik is not going to be able to make this, right? This
Right.
is some kind of four-legged animal, okay?
Yeah.
What was interesting about these tracks in particular was their age. Okay, the stratigraphy on them. They're from the lower part of the Middle Devonian. So let me show you what that means. Okay, so here are our first tetrapods, Canthostega and Ichthyostega, right? And Elgonurpaton might be in that group. Tiktaalik is right here. Eusthenopteron, the fish we talked about, is right there.
Yeah.
Where are the tracks found? They're found way back here in the Eifelian. So these tracks are 25 to 30-ish million years older than our earliest tetrapods, right? They are 12 million years older than Tiktaalik. They're even 6 million years older than Eusthenopteron.
Mm-hmm.
So that means we've got animals like this guy right here that are walking around underwater with 4 limbs before we have 4-limbed animals, before we even have Tiktaalik.
Mm.
So you can see why this is a problem,
Yeah,
right?
just for
Um,
clarity too, just as I'm looking at this, I got a little bit skewed with the time. The time is from oldest to the left, newest, more modern to the right, right?
correct. Yep.
Yeah,
So this is more recent. This is older over
yep,
here. Yeah. So you've got what looks like the final product appearing before
yeah,
stages leading to that product,
right.
right? That's a problem for the
Mm,
evolutionary model. And so when this first came out, there was a lot of debate, and some of the original authors on Tiktaalik, they were saying, well, can we be sure about the interpretation of the tracks or the dating of the tracks, or maybe Tiktaalik could make these kinds of marks. And there was a lot of debate going on, and people were thinking through these things. And so just to kind of illustrate once more what's going on here, right? Here's Euthenopteron, here's Tiktaalik, or sorry, here's a tetrapod like Ichthyostega, right? And so Neil Shubin and his colleagues, they predicted that there would be an animal that would fill this gap at this time,
mhm.
right? And they found it. It's Tiktaalik, okay? But our Zekelme tracks are showing that there's an animal like Ichthyostega that's around before even Euthenopteron.
Mm, fascinating.
Yes. And so what was the response to this? Well, in 2015, Spencer Lucas published a paper where he tried to argue that the Zekelme tracks are not footprints. He thought maybe they were what are called feeding traces from a fish. So basically, a fish is swimming along, sees something in the mud it wants to eat, it shoves its face in the mud and leaves an impression behind, right? Like a dent in the mud. And so he says, we know that these are not footprints because there's no obvious toe marks and because there's no overlapping prints. Okay. Now let me show you. Okay. That was Spencer Lucas's argument. No overlapping prints, digits aren't clear. Spencer Lucas never went to go see the fossils. He's just writing off of the pictures that he saw, right? He's responding to the paper. Um, Kvarnström et al., 2018, they say, oh, no overlapping prints? Here they are. You've got prints totally overlapping on each other.
Mm,
And digits aren't clear? Digits are pretty clear.
yeah,
You've got some digits going on there, right?
yeah,
So they're saying no, actually, this is very, very clear that these are tetrapod tracks. And they're very confident in the stratigraphy of this. They think that these are, in fact, older than Tiktaalik. And more recent publications that have been coming out by people working in this field have, for the most part, accepted that, yeah, this looks like there are tetrapods walking around before Tiktaalik.
yeah.
Um, so what are your options here? So you got this predicament, right? Where you've got the end product appearing before the stages to get to the end product. Okay. Now, at that point, it might be tempting as a creationist just to be like, haha, we got you, right? Like, it's
Yeah,
not true. Um, Obviously, I don't think that's really that helpful, right? At the end of the day, we
right.
want to think positive model building. What can we do with this? So what's exciting to me about this is that the evolutionist suddenly finds themselves in the exact same place that creationists have been for years.
Mm,
Okay, so creationists, well, let's start with evolutionists. Evolutionists for a long time have said, hey, we've got this, what appears to be morphological change, right? An animal changing over time in the rock layers as you make your way up, right? So the more primitive ones down here, and then more and more, it's more advanced, and the final ones up here.
mhm,
And they say, what else could that be except evolution? Right?
mm,
I mean, it's got to be evolution.
yeah,
And we've always said, well, maybe there's another reason for that. Right? And they're like, oh, you guys are so silly. There's no way. It's got to be evolution. Okay.
mhm,
Suddenly, they're in the exact same situation where they've got animals buried in a particular order,
mhm,
right? That shows a morphological change that looks like evolution's happening at that time when they know, in fact, the end product was already down here.
mhm.
So we're in the same boat, which is really interesting. And we don't typically find ourselves in the same boat, right?
Right, right.
So then we want to ask the question, okay, why did their prediction work? Like, if that's not actually when tetrapods evolved, why
Mhm.
did they find Tiktaalik there?
Yeah.
And I think that's a really interesting question. And
Mhm.
so I was thinking about this, writing about this for quite a while, and I stumbled upon a philosophy of science book. And the author of the book, I think his name is Vicker. Make sure I get this right before I say it. Vickers. So the author of this book, his name is Vickers. And he is trying to argue, are there examples of future-proof science? Are there things we can find in science that will be true for all time, right? They have no chance of ever being disproven. He has a whole chapter in the book about Tiktaalik. So I was like, oh, I'm going to check this out, right? This is interesting. So he says evolutionists were wrong to try and argue that Tiktaalik was something more important than it was. Okay. And so let me actually want to read to you what he says, because it's super, super interesting to hear from someone who's not a creationist. Okay. So here's what Vickers says. Let me paraphrase first of all. He says, the reason the Tiktaalik prediction worked is, and here's a quote from him, it had quite a high prior probability given the empirical knowledge of the day. Okay, so let me explain what he means by that. He says, now imagine a serious and dedicated explorer of the phenomena. Okay, these are his original quotes. An empirical scientist who proceeds without ever thinking about the theory of evolution. With intimate knowledge of the species on either side of the divide and the way they relate to each other, this empirically minded scientist might half expect there to be other species in the fossil record functionally and morphologically in between the fish and the amphibians. Furthermore, the scientist would have a good sense of where to look, given the strata where the other species were found, without for a moment assuming macroevolution. That's what he says. And I'm like, you're basically just explaining it to a creationist how they can do creationist paleontology, right? That's kind of cool. Okay. And then he says this, thus we reach the conclusion that the case for evolution theory shouldn't put too much weight on the specific Tiktaalik prediction. It is no silver bullet. Okay. So his point is this.
Fascinating.
Tiktaalik wasn't that big of a stretch. It sounded like it was a really big, like, if we get this right, our theory has to be right kind of thing, right? That's how it was built. That's how it seemed. But Vickers points out, no, actually, people were doing this before evolution. If you read his chapter, he talks about, people like Richard Owen and people like that, Cuvier in the 1800s, they were looking at the fossil record and they were like, yeah, well, we found this thing here and that thing there. There's probably something that kind of looks in between them that we found right there. And they're finding it. And they weren't evolutionists. And so Vickers is saying, look, you could actually have a completely different prediction or a completely different theory or paradigm and make a similar prediction.
Yeah.
And so it wasn't the, silver bullet that it sounded like it was.
A lot of it depends on your presuppositional ideas.
Yes. Yeah. So, then the question becomes, what do we do with it? Right? How do we explain it? And how does the evolutionist explain it? And so, I don't know the total answer to that yet, right? That's going to require further study. But, my guess is we're looking at some kind of environmental transition, right? So maybe a shallowing upward sequence, maybe something like that, right? That is giving you this perspective. And I think this fits in with Kurt Wise's idea of a floating forest. And I'd love to see some creationists run with that because his model, floating forest model, predicted that there would be animals that would have some, like, be kind of aquatic, kind of not aquatic, right? That would be living there. And Tiktaalik fits that really well.
Yeah.
And then I will go ahead and point out too that Asher and Garner in 2018 at the ICC, they presented a baraminology paper on these animals, and they found very clear discontinuity between Tiktaalik and four-legged animals. So they're, all these different lines of creationist reasoning are kind of pointing to the same idea that this is not a real evolutionary transitional sequence.
Right. This is more ecological.
Something like that. Right. And so you'd have to figure out, do you think these are flood rocks or pre-flood rocks? And then how would you explain that? But, really, obviously, we needed to do detailed field work and studying of the fossils and those kinds of things.
Right. Yeah. And what about continuity? I mean, what do we have to say about continuity? Because there's certainly continuity there, though, right? When you see those fossils, you still have continuity. Is there anything we can say about that as creationists?
Yeah, that's a good point. Homology is real, right? I mean, like, they're made with bones, we're made with bones, right? And they're the same kinds of bones. And you can recognize them that way. And so there are design blueprints, I think, that are at play here in terms of how God created his creatures. And Tiktaalik does appear morphologically intermediate, right? So, for instance, ignoring stratigraphy for a minute, the phylogeny is going to keep showing Tiktaalik as the closest thing to a tetrapod without being a tetrapod.
Right.
right? I mean, that's where it's going to fall. And so there are real nested hierarchy, real design patterns that are at play there, blueprints that God used in creation. And there's functional reasons for that too, right? Like, and I think specifically, why is Tiktaalik built this way? This is where we can go back to some of those creationist publications from the middle 2000s, and late 2000s, where they were saying things like, yeah, God is going to make, if he wants an animal to be, like shallow water specialist, I mean, having a fish that doesn't have to actually paddle, but could kind of like creep along and stuff, that has a flat head where it can poke its eyes out of the water to grab things. Yeah, Tiktaalik's a fantastic design, right?
Mhm.
And so functionally, the stuff works together, right? And works with its environment. And we do see God working in terms of blueprints. But ultimately, I think this is a big area of neglected work for creationists.
Yeah.
We are so focused on discontinuity, we don't think about continuity many
Right.
times.
Yeah.
And we should, because
Yeah.
it's a real part of nature.
Yeah. So in a sense, God has an environment in his mind before he creates, and he has a specific ecological design for that environment, and he can draw from a fish blueprint, and he can draw from his tetrapod blueprint, and sort of create this middle of the road blueprint for this middle of the road ecology.
Yeah, it could be. I mean, or it could be, maybe it is more drawn out, like, kind of the way the evolutionist pictures the tree, right? Maybe when he's thinking about, designing four-legged animals, he says, okay, I'm going to take that fish shape and I'm going to modify it to make something that's going to walk on four. I don't know, right?
Yeah.
We don't know what was going on in the mind of
Yeah.
God.
Yeah.
But it's still design. And I think sometimes we're scared of things that look like something and something else at the same time because it
Yeah.
sounds like evolution.
Right.
But this is a regular part of life. There's all kinds of things like this in nature,
Yeah.
and we need to be okay with that and realize God's design is good, and part of his good design is the shared features of
Yes.
things. I
Yeah.
mean, for instance, you share the same elements as rocks, a lot of them, right?
Mhm.
And at the same way, we have cells, and the simplest organisms have cells, right? Or are cells. And so there is this continuity that runs through all things, all created things.
Right.
We're part of the creation. It's not surprising. We were made out of dust, right? There should be connections that are
Right.
there, and Tiktaalik reinforces that idea.
Yeah, and like you said, for the audience, if they're interested, 19th century scientists and philosophers were talking about this continuity, not in terms of evolution. They were talking about this before Darwin.
Yeah.
They embraced this sense of continuity without talking about evolution.
Hmm.
So it is really interesting, and I do think it's a whole area for creationists to begin working. And I'll put a couple of links in for some videos that I've done on that for anyone who might be interested.
And I think really, a big lesson for us as creationists coming out of this whole Tiktaalik story is, your faith is not determined by scientific arguments, and when you hear something that you don't know what to do with, right? That sounds against scripture. It's really easy to start thinking like, oh, maybe everything's wrong, right? Like maybe I need to give up on the Bible and stuff. And my encouragement to you, and we see this again and again and again, time and again, is be patient, wait, have faith. Trust that the word of God is what it claims to be, right? That God really did do what he said he did. Because if you wait it out, typically somebody discovers something and they're like, oops, we were wrong about that, right?
And
And yeah, go ahead.
I think it'd be okay to pray about that too, right?
Yes,
I mean,
absolutely.
pray that the Lord would bring these kinds of things to bear in real life.
Yeah.
That would be something that would be worthy of prayer.
Yeah. And I think there's been lots of examples of this when you look at the Coconino sandstone and when you look at rapid granite formation and lots of transitional form examples, including Tiktaalik, right? And these serve as, when scripture tells us, right, look back at God's works, right? When you're struggling, look back at how God has worked through history and through scripture and through you and has preserved you, right? And that's an encouragement to you. It's the same kind of thing here. Look at what's come before and realize, oh yeah, that was a challenge and that kind of went away. And that was a challenge and that kind of went away. And I'm not saying every challenge is going to go away in our lifetime, right?
Yeah.
But what I am saying is that, we can boldly and firmly depend on God's word and do science and learn about science and not be scared.
Yeah. Cool. Any final thoughts, concluding thoughts that you have, Matt?
No, I just say I think if you're interested in, these kinds of things, creationist paleontology, I have to put in a plug. I think the Masters University is a great place for you.
Absolutely.
We have biology and geoscience majors, and specifically, you can come here and study paleontology. It's an emphasis in our biology program. And so, if this kind of thing is interesting to you and you want to learn more about this, it's a great opportunity.
Okay, great. So look up Dr. Matt McLain at the Masters University if you're interested in attending a great university that has a creationist perspective. Okay, well, I think we'll wrap it up there, Matt. I want to thank you again for
Yeah,
being with
thank
us.
you.
And who knows what we'll chat about next time. It's exciting stuff. This is great. I love it. I'm sure the audience also appreciate that. So that's all from me. Ken Colson here at Creation and Following. Don't forget, pound that like button. Always, if you were encouraged in any way by this video, then hit that like button, subscribe, ring the bell for easier access. Pray. I really appreciate that. There's a PayPal link if you're interested in giving. That'd be great too. And we'll see you next time.